we are going to solve fractional equations. So if you would look at your packet, I'm looking at number 29. And if you read the steps, the first step says to find a common denominator. So we have a denominator of 6, 10, and 15. So I think probably a good denominator would be 30 because 6, 10, and 15 all go into 30. So if that's the case, in order to make this 6 a 30, I would have to multiply by 5, right? But what I do to the bottom, I have to do to the top. Oh boy, I'm going to write over that 29, but that's a 5 there. Okay? Now, to make the 10 a 30, I would have to multiply by 3. Again, what I do to the bottom, I need to do to the top. So I'm going to stick a 3 right out in front there. To make the 15 a 30, I would have to multiply by 2. Oops. What I do to the bottom, I'm going to have to do to the top. So I'm going to multiply that by 2 as well. All right, now, so we found a common denominator. Notice that our common denominator is 30. Number 2, step 2, says to cross off the denominators. So when we have an equation, which we do here, we have an equal sign there, we can cross off all the denominators. So since all the denominators are the same, we just simply go, whoop, hold on, there we go. All right, then we're going to keep our numerators. So I have a 5 times that x minus 4, so I'm going to distribute that through. So that's going to give me 5x minus 20 plus, and now I'm going to distribute the 3 through to the x minus 2. So that will give me 3x minus 6 equals, and now I'm going to distribute or multiply that 2 through to the 31, which will be 62. Okay, now we have an algebraic equation here, so we add like terms. So I'm going to have 8x minus 26 equals 62. I'm going to try to get that x by itself, so we're going to move that 26 over to the other side. I end up with 8x equals 88. Solve for x, divide by the number in front, and then I get x equals 11. Da 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 da. Not so bad, right? Now, in this case, what we want to also check for, and in this question it's not really going to be possible, we want to check for something, called extraneous, that's an S, roots. And basically what that means is we want to check our answer, in this case x equals 11, and we want to plug it into the denominators of our original equation just to make sure that we don't end up with a denominator as 0. Now in this case, we look at our denominators and they're already constants. They're 6, 10, and 15. So there's no x value that I can plug 11 into to potentially get a denominator that would be 0. So in this case, we have what we would say are no extraneous roots. Now maybe that's a little bit confusing. Wait till we get to the next one and hopefully it'll make a little bit more sense because it'll be a little bit different. So watch. All right, so let's look at number 32. So if you look at number 32, we're going to follow the same rules. So we want to find a common denominator. Now in this one, in this case, it's a little bit different. I'm going to look down here on the far right, on the bottom here, and I see x squared minus 9. And so little alarms going off in my head saying, oh, that's the difference of 2 perfect squares. So I'm going to make that x minus 3 and x plus 3. So if that's the case, I look at my denominators and I say, I have a slight problem because here this says x minus 3, but here this says 3 minus x. If you remember, when they're opposite each other like that, we can simply take this 3 minus x. I'm going to flip that baby around and make that x minus 3, but I need to multiply by a negative 1. Do you remember that? Okay? Because now everything's kind of in the right order, and now I can start to look for a common denominator, which is my first step. So I notice that I have an x minus 3, I have an x plus 3, and then in the far right-hand side, on the right side of the equal sign, I have both. So I'm thinking that my common denominator should be both x minus 3 and x plus 3. So if that's the case, this first one is going to get multiplied by an x minus 3. But remember, what you do to the bottom, you have to do to the top. Now if I look at this middle fraction here, it already has an x minus 3. So what that one's missing is an x plus 3. But what you do to the bottom, you do to the top. Now if I look at this far right-hand fraction, well, it's got everything. Remember, this is equivalent to x minus 3 and x plus 3, so I'm good. So I look at my second step, and my second step says to cross off the denominators. And remember, we can do that because we have an equation, we have an equal sign. So I'm just simply going to go like this, they're all gone. Okay? All right, now we're going to simplify these numerators. So I look at the first numerator, I have 1 times x minus 3, which is obviously just x minus 3. Now let's be a little careful here, because in the second fraction here, look, I have minus a negative. And remember that that means plus 2. And then times that x plus 3. I'm going to distribute that through in the next step. I just wanted you to see that that minus a negative turns into a plus 2. Okay? And then equals 4. Okay? All right, so now let's distribute in that next step. So we have x minus 3 plus 2, what am I doing? 2x, let's distribute, plus 6, right, equals 4. So let's add like terms. I have 3x plus 3 equals 4. Let's move this 3 over, right there, and we have 3x equals 1, and when I divide by 3, I have x equals 1/3. Now on the last question I was talking about extraneous roots. This will make a little bit more sense. So if you look here on the right side of this line that I drew, this was the original equation. Okay, so I want to take my answer over here, and what I want to do is I just want to put it in this denominator and make sure that when I plug in 1/3 where that x value is, notice, so I'm going to plug in a 1/3 here and I'm going to add 3 to it. Do I get 0? If I do, it's called an extraneous root. If I don't, we're all good. So that's fine. And when I plug in 1/3 plus 3, I don't get 0, so we're good. Now I'm going to take that 1/3 and I'm going to plug it in here. If I do 3 minus 1/3, you can do it in your calculator. Just, think about it. 3 minus 1/3 is not going to give you 0. So that is not an extraneous root. We're still good. If I plug it in here, into that denominator, and I do 1/3 and I square that, 1/3 if I square that is 1/9, and 1/9 minus 9 doesn't give me 0. So that is not an extraneous root. So 1/3 would be then my answer. If for some reason I got an answer, like here I have x equals 1/3. Let's say I had an answer of x equals 3. When I plug in x equals 3 into either this denominator here, portion of the denominator, or this portion here, I will get an extraneous root, because if I plugged in x equals 3 in either of those spots, I would get 0. So what I would do is I would reject that answer of x equals 3, and I would say, well, that can't be an answer because it's an extraneous root. Okay, we'll cross that bridge when we get to it. You will see some questions like that.